Hi everyone! In this video, we will analyze a hypothesis test and make conclusions. A quality control manager at a pharmaceutical company suspects that the average purity level of a drug is not 98%. A test yields a z-statistic of 2.58. Assume the significance level is alpha equals 0.01. What is the p-value and the conclusion for this hypothesis test? Because we're doing a hypothesis test, we first need to identify the two hypotheses, the null hypothesis and the alternative. A null hypothesis needs an equal sign, or a lesser than or equal, or a greater than or equal. An alternative hypothesis has a less than, greater than, or not equal to. The null hypothesis must have some form of an equal sign. So let's go look through the information that was given to us. And we see that the average purity level of a drug is not 98%. Is a not equal to, and we are looking for the average. So this is a mu. So our null and alternative hypotheses have mu, and the alternative is not equal to 98%, which is 0.98 as a decimal. And this means that the null hypothesis is that it equals 0.98. We have a couple more things that were given to us. The z-statistic or test statistic of 2.58 was given to us, and a significance level of 0.01. So let's write those down too. Alpha was given to us as 0.01, and the z, or the test statistic, is 2.58. We were asked to find the p-value and a conclusion, so we're going to write that down just to keep everything organized over here, what we have and what we are looking for, the p-value and the conclusion. Now let's go back and look at our hypotheses. The alternative says mu does not equal 0.98. When we have a hypothesis or the alternative that it does not equal, this tells us that we have a two-tailed test. And we have a wonderful tool to our advantage using Desmos that will calculate our p-value given all of the information that we have. So let's go ahead and use this tool on Desmos. We need a two-tailed test, so we will move the blue dot down to the two tails down here. So we'll grab it and slide it down and then release the mouse so we get our two tails. The significance level we were given is 0.01, which is right there, so we don't need to move the purple slider, but we do need to move our test statistic to 2.58, and we need to move it. It gets kind of particular. And there we go. So now we have our test statistic on our graph, which has given us our p-value. It was calculated for us as 0.0098. And since everything's been rounded to two decimal places, let's go ahead and round this to two decimal places. So it makes it 0.01. And now we can compare our alpha and our p-value. Alpha and our p-value 0.01 is our p-value, and alpha is 0.01. It's not very often that we will have a p-value and alpha equal each other, and even the test statistic and the critical value are the exact same number. But because we actually hit into that rejection region, we will reject the null. Even though these are equal to each other, we often say that we're looking for p to be less than alpha to reject. However, if it is less than or even equal to, which in this case they are equal, then we will continue to reject the null. Another way to think about it is that these actually fell at the exact same place, 2.58, and so it just did get into the rejection region. So we are going to reject the null hypothesis because it fell outside of the fail to reject region. And even though it's right there on the brink, it did still fall within the rejection region over here. And so now we found the p-value and we have our conclusion, and we're all done.